We know all about doing the trig functions, right, with right triangles. So what they're going to do now is they're going to give you like a real life test to see why do you need to know this stuff? Why in the world do you have to find angles and sides and all that kind of thing? Well, I'm glad you asked that question because they're going to show you. Let me just talk about a couple little things here. Let's pretend this is the ground right here. Dominique's been bugging me about using different colors, so I'll make that green for grass. Is that okay? Does that look good? All right, and then let's say you had like a wall or something. Like, oops, like that. All right, and we'll make that. That looks like brick color about right there, doesn't it? All right. Well, that's a little redder than that looks. Doesn't that look much more red than that? Anyway, that's okay. There's our brick. There's our brick wall. And so a lot of times they're going to ask you to do stuff like this. Let's just go yellow. They're going to say, okay, you got somebody up here, you got somebody down here, and you've kind of got like a line of sight. And so you're looking from here, and you're seeing a point down here. So this is your line of sight. Everybody with me on this? Okay, so look what you have. Assuming that the building is vertical, okay, and the ground is horizontal. It's not always a safe assumption, but that's what we're assuming on these problems, okay, that the building would be vertical and the ground would be horizontal. This is our line of sight right here. So this angle right there, they call the angle of elevation. All right, so let's say somebody's looking right here. This is where they're looking from. This would be the horizontal, wouldn't it? So the angle of elevation is from the horizontal up to that line of sight. Everybody following me on this? Okay, so you're looking from here up to here, or the other way around. But let's say somebody's here and they're looking up to the top of this building from this particular point right here. That angle would be called the angle of elevation, right? Because you're elevating, you're looking up, aren't you? Because if you look straight across, that would be horizontal. But what are they doing? They're elevating, right? So they're looking up, the angle of elevation. Well, there's another angle. Let's say you're at the top. And we'll do this in that green again just to stay color coordinated here. Let's change that to that. So where would the angle of depression be? We have a thing called the angle of depression because depression means to go down. Would that right there be the angle of depression? Well, think of the angle of elevation. The angle of elevation is from the horizontal up, isn't it? So what do you think the angle of depression? Yeah, it's from the horizontal down, exactly right. So let's draw a horizontal out like this, okay? And what would the angle of depression be? It's from the horizontal, where? Down to the line of sight. You with me on that? Now, what do you think might be true? This is called the angle of depression. It's not because it's sad or anything. It's because it's going down, right? That's why they use the word depression, for mental depression is because you're down, right? Not up where you should be. So the angle of depression, angle of elevation. What do you think might be true about these two angles right here? Why are they equal? You got it. They're alternate interior angles. Exactly right. Because, again, we're making assumptions here that horizontal, this is horizontal and this is horizontal. Okay, not really assumptions, but we're saying that they're both horizontal. So if they're both horizontal, they must be parallel to each other, correct? So I got two parallel lines cut by transversal. So that means the angle of depression is exactly the same as the angle of elevation. You might want to jot that down somewhere. The angle of depression is equal to the angle of elevation. So that should be pretty helpful. So sometimes they'll give you the angle of depression. Sometimes they'll give you the angle of elevation. Or sometimes you might have to find it. You might want to find what those angles are. Okay, and they'll give you different stuff. They'll say, let's just make one up. Let's say you're up at the top of this building, and they tell you the angle of depression is 10 degrees. All right, so the angle of depression is 10 degrees. That's the angle. You know what a common mistake a lot of people make with angle of depression? What would your guess be that a common mistake is as far as angle of depression? Where do you think they put the angle of depression? It's not right. This one right here? Well, that would actually be okay. A lot of people put it up here. If I say angle of depression, they're taking it, they think, oh, it's this top angle right here, and this is going down. But this right here is not the angle of depression. Does that make sense? Right? This right here is the angle of depression. But the angle of depression is the same as the angle of elevation. So if that's 10 degrees, then what's this angle down here? That's 10 degrees as well. Well, we could also find this angle right here, couldn't we? What would this angle right here be? It'd be 80 degrees, right? Because this is vertical, this is horizontal. They make a right angle. Would you agree? All right. So look at that. You know all that stuff. What if they told you the, let's say they told you the distance along the ground up until you got to the building, all right? And say, we'll just make it easy. We'll say it's 100 feet. And they're going to ask you, how tall is the building? So they're going to say, okay, you've got an angled depression of 10 degrees. The distance, right, from what you're looking at, okay, sometimes they'll say there's a boat out on a river or ocean or something, and, you know, they're on top of a cliff, and they measure the angle of depression to be 10 degrees. The boat is 100 feet away from, these numbers probably aren't very good numbers, but anyway, it's 100 feet away from the cliff. Everybody with me on that? So this would be the cliff. The boat would be right here. It's 100 feet away from it. That means that's the horizontal distance that the boat is away from the cliff. And you want to find out how high the cliff is or how high the building is. So what are we going to call that? Call it, I don't know, H for height. Whatever. You can call it anything. It doesn't matter. Just call it H for height. Yeah, it'd be the altitude. Yeah. All right. It'd be the height of it, right? Because it's perpendicular. So what would you do? What math would you do? You know a few things already. Now, if you wanted to, since it has so much junk in there, especially like word problems have so much stuff all written all over the place, sometimes it's helpful to just redraw the triangle nice and clean without all the junk around it. So this would be H, this would be what? 100, and what is this angle right here? That's 10 degrees. That looks a little cleaner, doesn't it, without all that stuff around it? Because sometimes they draw these real fancy pictures in the book and all that kind of thing. So what are we going to do? How are we going to solve for H here? Do the X and Y thingy? Okay, let's use a trig function, right? Let's use a trig function. And we got to figure out which trig function we're going to use. Well, if we're going to use this angle right here, this 10 degrees, I got this side and this side. This is opposite, this is adjacent. That's why they said tangent. So we're going to take the tangent of the angle, always take the tangent of the angle, is equal to the opposite over the adjacent. Well, if we're talking about this angle right here, H is opposite, isn't it? Over the adjacent, which is 100. And now we just solve. Multiply both sides by 100, plug it into a calculator, and we've got the height of that building, or cliff, or whatever. Can't you just do what?
So how do you plug this in our 100?
Yep, it's right there. Alright, so on this calculator you go 100, tangent 10. But what if you had a TI 30XA? 10 tangent times 100. Okay? So make sure you know how to use your calculator. So 17.6. So the height right here would be 17.6 what? Feet. If that was 100 feet. Make sense? It's pretty easy, isn't it? We good? Now look, if I said this was my, how would I say this? If I said, you know, a person was standing here and looking up here. Well, if they're standing on the ground, their eye wouldn't actually be right here, would it? Their eye would actually be right here. Now, they could be laying on the ground and their head's right on the ground and looking up. That's, I mean, that's legitimate, right? That could happen. But sometimes they'll say this. Okay, the person is 6 feet tall, right? And the angle of elevation is 10 degrees, and they're 100 feet away from this. So if this person was 6 feet tall, then what are you doing? You're actually finding a shorter height then, aren't you? Okay, right. Everybody see that? So, like, let's do this. Let's go different color here. Well, watch. Let's just see. I don't know. So now, you know what? I was just trying to go with my instinct. We should probably do a problem, shouldn't we? Because I think I'm messing that all up. And I think they have an example very much like that in here. Yeah. Look at the castle. Yep, angle of elevation. Yeah, that's perfect. I knew I had one like that in here. All right, let's draw this thing. I'm looking at page 574. Everybody looking at that? So look what they have here. You've got a castle. Now I'm not going to draw the fancy picture, with the castle. I'm a terrible artist. I'm not even good enough to be called a terrible artist. The word artist and my name should never be said together as far as drawing stuff.
Just draw a bunch of squiggles.
And then this kind of looks like this. Alright, this thing right here is the tower. Okay, that's how tall the tower is. Did they tell you that height? Yep, 190. And that's all the way to the ground, isn't it? Yep. So that's 190 feet. That's all the way to the ground. And then, they don't tell you the horizontal distance, do they? So we'll call it x. Now, what else do they tell you?
38 degrees.
It says if Leah, right, is 5.5 feet tall, how far is she from the castle to the nearest foot? So this is her eyeball right here. Everybody see that? I said that weird? How could I say that weird?
We've had this whole conversation before. Sorry.
What, with eyeball? How did I say it? I said eyeball. How's that weird?
Eyeballing. Remember?
Oh, eyeballing. Right. Yeah. So anyway, here's her eye. Is that all right? Here's her eye. And let's see.
Just use her whole body.
See how I can do this.
Just draw her whole body. Just draw her head. Just draw her head. That's what I
So we'll just say it's the top
See,
of
look,
her head.
Look at my body. See?
Okay, we'll just say it's the top of her head right there. Okay, and but what are we gonna have to do here? That 190. You know what I should have done? I should have done this. I should have brought this down, right? Because she's standing. I don't know if I can draw this very well. This is where I was having a problem with
okay, look, just
the other thing. Like that. I don't know what I'm doing.
It's not that hard. Just like that.
I'm trying to...
Look, like that.
Okay, I know what we're going to do. Watch this. Okay, I know what I'll do. Watch this. So, we'll just put... Shh, just bear with me. Come on. Oh, I made that thing yellow, too. I don't want to make that yellow. I'm getting it. Don't worry. Just be patient. Where you guys got to go anyway? You guys are acting like you're in a big hurry to go somewhere. Like I got to finish this in 2 seconds. Alright, there we go. That's 190 feet, but what is she doing? That's how I should have drawn it in the first place. Watch this. We want to find out... Yeah, that's right. Yeah. Okay. So she is looking at an angle, right? 38 degrees. So she's looking at 38 degrees. And how tall is she? Leah is 5.5 feet tall, right? That's this yellow distance right here. Everybody follow me on that? But what's the 190? The 190 goes all the way down to the ground. So when we talk about our triangle, are we using 190? No, what are we using? We're using 190 what? Minus 5.5, which is what? 145 or 180. Yeah, 184.5, right? Yeah, because look. Because 190 goes from here all the way to here. But this angle is taken from here to here, isn't it? All right, because that's where her eye is. So if you come straight across right here, so the 190 is not the number we're going to use in our trig function. We're only going to use from here to here. Got it? So how do I know that's 184.5? Where are you going? Oh. Yeah, because you take her height away. From this is her height, the 5.5. You take that away from 190, and you've got the height right here, don't you? All right. And then it's pretty easy. What are we going to do? We're going to go use this angle. This is opposite. This is adjacent. We'll use the tangent again, just like we did in our little made-up problem earlier. And so we'll just do that. The tangent of 38 degrees is equal to the opposite. Now, we're not using 190, though, are we? We're using 184.5. And that was a little bit tricky. 184.5 divided by opposite over adjacent, which is x. Look at the math, though, on this one. The math is a little different, isn't it? Remember how we did this the other day? Just switch these two right here, so it's x equals 184.5 over the tangent of 38. A lot of people get confused on that arithmetic, but it's basically just cross multiplication, getting x by itself, if you want to think of it that way. All right, and then you throw that into a calculator, and hopefully we'll get the answer that the book gives us. 184.5 divided by the tangent of 38, and 236. Does that sound right?
I got 0.5.
You got 0.5? Yeah, it should be. Yep. I don't know why you got 0.5. Did you do it? Well, don't do that. You got to divide by the tangent. You have to divide. It's 184.5 divided by. So if you use one of those TI-30XAs, you would do this. You would go 184.5 divided by 38 tangent and then equals. And then you should get this exact number. Okay, it shouldn't be any different whatsoever. So it's 236 point, what'd you say it was? 1? Okay, because it was 1/4. The 4 doesn't round the 1 up, so that's what it would be. And that's how many feet. That's how many feet it is from here to here. 236.1 feet, yes.
What if it gives you like 50, if it says like tangent 50 degrees equals like 20 divided by 7 or something? Or like the opposite is
Well,
like
you wouldn't have a
7.
variable in there.
You would
I mean,
you'll always have a variable.
Yeah. You're going to have a missing part. Yeah, sure, because if you didn't have a variable, then you'd know what you were solving for already. You wouldn't have to solve for it. All right, well, let me give you a few problems to do here. Now, that was actually pretty easy. Some of them, a couple of them anyway, are not super easy. If I recall. I haven't done these recently, but if I remember, you will have to really concentrate on a few of these. So it's pages 577, 578, and it's 4 to 11. So it doesn't seem like that many, but it does take a little bit of thought. I really want you to see what I did right here. I took the picture that they gave in the book, and I drew my own pictures here. Right? Just use lines and angles and stuff. That's all I did. I didn't do that. Did somebody? Uh-oh, that's not good. My light is shining red. Why is it doing that? Crud. That's not cool at all. It might mean my bulb is going bad, and I need it tonight to teach my photography class. Oh my goodness.